Common and IUPAC name of some of the important halides. This one is Cl is attached to secondary carbon. We call it secondary butyl chloride. And this is the first carbon, second carbon, third carbon, fourth carbon. IUPAC name is 2-chlorobutane. This is neopentyl bromide. Earlier we have done neopentyl chloride. This is neopentyl bromide is the common name because this carbon is quaternary carbon. It is attached to 3 carbon this side and 4th carbon this side. But this is primary halide because Br is attached to CH2 or primary carbon atom. IUPAC name 1-bromo. This is the first carbon, 1-bromo, 2,2-dimethyl. Second carbon is attached with 2 methyl groups. Dimethyl propane because the longest chain contains 3 carbon atoms. This compound is tertiary butyl bromide. Why we call it tertiary butyl bromide? Because Br is attached to tertiary carbon atom. That is the carbon atom attached to 3 more carbon atoms. IUPAC name is 2-bromo 2-methyl propane because Br is attached to second carbon. It is also attached to 1 methyl group, so we call it 2-bromo 2-methyl propane. This is vinyl chloride. Vinyl chloride is the common name. IUPAC name will be chloroethene. And this compound is called allyl bromide. Allyl we call it whenever you have CH2CH, CH2 double bond CH, CH2Br is allyl group. We call it allyl bromide. Here remember double bond is preferred over halogens. So this will be first carbon, second carbon, third carbon, 3-bromo propene is the correct IUPAC name. These are aromatic compounds. Here we call it orthochlorotoluene because Cl is present at second position. Whenever it is present as adjacent to methyl group, we call it orthochloro. Means chloro and methyl group are at 1 and 2. We call it orthochlorotoluene. IUPAC name is 1-chloro-2-methylbenzene. We have preferred chloro because that is functional group and methyl is less preferred. So 1-chloro-2-methylbenzene. Also alphabetically also chloro will get the preference. This compound is benzyl chloride. Here this is the carbon atom which is attached to chloro and this group is called phenyl. So IUPAC name will be chlorophenyl methane. CH2Cl2 is common name methylene dichloride or methylene chloride. Dichloromethane is the IUPAC name. CHCl3 is most important chloroform. IUPAC name is trichloromethane. CHBr3 will be bromoform, tribromomethane, and CHI3 will be iodoform, triiodomethane. CCl4 is called carbon tetrachloride. IUPAC name is tetrachloromethane, and this compound is normal propyl fluoride. IUPAC name is 1-fluoropropane. Next, we are taking questions based on nomenclature. Draw the structure of all the structural isomers that have the molecular formula C5H11Br. Name each isomer according to the IUPAC system and classify them as primary, secondary, or tertiary bromide. The first one is 1-bromopentane. Br is attached to primary carbon. It is called primary halide. Second one is 2-bromopentane. It is secondary. Third one is 3-bromopentane. This is also secondary. Fourth is 1-bromo 3-methylbutane. It's primary halide. 2-bromo 3-methyl. Bromo has to be preferred over methyl group. So it will be 2-bromo 3-methylbutane secondary. 2-bromo 2-methylbutane will be tertiary because bromo group is attached to tertiary carbon atom. This is called 1-bromo 2-methylbutane. This is primary. 1-bromo 2,2-dimethylpropane. This is also primary. This can be called as neopentyl bromide. So these are IUPAC name of 8 isomers of C5H11Br. Next question, write IUPAC name of the following compounds. Here we have Br group and double bond. Remember, double bond is preferred over Br group as far as possible. Here we have first carbon, second carbon, third, fourth, fifth carbon. There is a bromo group at fourth carbon. We write 4-bromo. Total carbon atom are 5 means pent. Double bond is after second 2-ene. That is the correct IUPAC name. 4-bromo-pent-2-ene. Here also counting is started from here 2, 3, 4, 5. 4-bromo. Bromo is attached with the fourth carbon atom. We have written 4-bromo. 3-methyl. With the third carbon atom, methyl group is attached. So we have to write 3-methyl. Pent-2-ene. Pent means total 5 carbon atom. 2 double bond is after second carbon. Ene means double bond. This compound counting will start from this side because double bond has to be preferred over alkyl group. A double bond is preferred over halogens. So this first carbon, second carbon, third carbon, fourth carbon. So 3-bromo, third carbon is attached to bromo, we call it 3-bromo. 2-methyl, second carbon is attached to methyl group, but1-ene. Double bond is after first carbon atom, we call it but1-ene. This one is 2-bromo, 2-methyl, but2-ene. Why? Now counting will start from this side because double bond will get number 2 from either of the sides. So now we have to start counting from here so that bromo also gets minimum number. Bromo will get 1 and alkene will get, double bond will get 2, 3, 4. So 1-bromo, 2-methyl, but2-ene. Here we have not preferred bromo because alkene will get, double bond will get the same number both the sides. Therefore bromo has to be preferred. Next compound, we start counting again from here because both the sides double bond is getting second. So bromo should be given preference 1, 2, 3, 4, 1-bromo, but2-ene. Here we have to prefer double bond over halogens 1, 2, 3, 3-bromo, 2-methyl propene. Next we are taking the bond length of CX bond, carbon halogen bonds, bond enthalpy and their dipole moment. CH3F has bond length 139 picometer, bond enthalpy is 452, which is highest due to shortest bond length, and dipole moment is 1.847. CH3Cl has got bond length 178, longer than CH3F because chlorine is bigger in size. Bond enthalpy definitely will be lower. This is 351 kilojoules per mole. Bond, that is dipole moment, is higher. Now this is surprising. Although fluorine is more electronegative than chlorine, so dipole moment of CH3F should be higher. But actually CH3Cl is higher because dipole moment is product of charge into distance, and distance is more in CH3Cl as compared to CH3F. That is why dipole moment of CH3Cl is higher than CH3F. This is most important point from entrance point of view. CH3Br has got bond length 193 picometer, bond dissociation energy is less, dipole moment is also less. CH3I has bond length 214, the dissociation enthalpy is 234, which is lowest because of longest bond length, and dipole moment is less because iodine is bigger in size and has less electronegativity.